EE-News is at the RISC-V workshop here in Barcelona, and we're meeting up with Dave Ditchell. He is the CEO of Esperanto Technologies.
Esperanto is a new chip company. We're formed from a lot of people with a lot of experience in building microprocessors at major companies like Intel, people who build chips for Spark and MIPS. And we really believe that RISC-V has the potential to be the new architecture of the future. Esperanto in particular is building a new chip for doing machine learning, or what's commonly called artificial intelligence. We're going to be one of the many companies building new chips for this RISC-V ecosystem.
So you see actually that there's a great future for the whole RISC-V platform, because I hear people say, okay, it's much more for smaller devices, but you have high aims.
Well, we think RISC-V can be used everywhere. Much in the same way that many years ago people didn't know what the Linux operating system would be for, but it became very popular because it was open. Because it was open, people could apply it in many different areas. We think the same thing is going to happen for RISC-V. It's an open instruction set, which means that when we develop software, many different people can develop chips which will all run the same software. And we think that's a great strength. And until now, before RISC-V, there was no open instruction set for people to commonly use. With RISC-V, there can be many different kinds of computers, from low-end, embedded, handheld devices, all the way up through supercomputers. Esperanto in particular is trying to build some of the highest performance RISC-V processors, and we want to make the world aware that RISC-V can be just as good for the high performance computing needs as any other type of CPU.
When can we expect some first samples or results of this development?
There's a lot of development work to go on. That's why Esperanto has 3 different engineers talking at this conference. We talked about the privileged instruction set, the new vector instruction set extensions that are going on, and a little later today we're going to talk about some techniques to make RISC-V very secure against some of the attacks like Spectre and Meltdown. One of the reasons we're talking about this now is we can get this previewed in front of the entire RISC-V community, get comments back so we don't inadvertently put something in the hardware that we think is secure and then later you find a bug. So that's the value of being open. We get 1,000 people looking at the proposed solutions here while we're working on our chip, and then we get the feedback then in enough time to put it in before the chip comes out.
You mentioned Spectre and Meltdown. RISC-V is a solution for that?
We think we do have a solution for that. In fact, just this week there's a new set of bugs coming out for Spectre and Meltdown. So we have some very generic techniques that we think can protect against this entire class of problems, and RISC-V as a new architecture has the opportunity to make it one of the most secure architectures out there. And we think the fact that the instruction set is very open means it's available for inspection, and when you think about security issues here, what are you going to feel more secure with? An open instruction set that's been inspected and has techniques for security that are reviewed by a wide community, or would you rather have a proprietary instruction set that's full of ancient, historical things in it that's never been reviewed by an open community? You really don't know what's happening in some of those closed architectures. So we think security and open instruction sets go together very well. We have people in Japan, the United States, we have several sites. We have a site here in Barcelona, Spain, as well as other sites in Europe.
Okay. Well, we're looking forward to see the outcome of all the research and development with Esperanto Technologies. Thank you very much.
Thanks a lot.